Yes, good morning, dear friends. In this lecture, we are going to discuss the concept of microwave. So, what exactly we mean by microwave? In nowadays, microwave communication becomes very much reliable, and there are wide scope and applications of microwaves in our day-to-day life also. We are using microwaves in our consumer products also, so that's why we have we must have to know the concept of microwave. Now, as per the word micro, we know that micro means 10 raised to minus 6, right? But here the word micro indicates tinyness. So, as tiny is nothing but a smallest part or very small part, right? So, small part of what? So, small part of some quantity, and that quantity we are going to discuss here is nothing but a distance. So, as all of we know that distance is always measured in meters, right? So, if we are measuring a distance, itself indicates we are measuring a length. So, the unit of length and unit of distance, both it is in meters as per the SI units, right? So, here we are measuring a length. Now, the next question arises in front of us, that for which quantity we are measuring the length. So, here we are measuring the length of wave. So, the term arises in front of us, wavelength. So, wavelength is one of the important parameter in your signal communication. Now, as all of we know that if we draw the waveform of a sinusoidal wave or a sine wave, so on x-axis it is time, on y-axis there is amplitude, right? Now, if one of the particle is moving along with this wave as the crust and troughs, right? So, this particle is covering a distance from this point and moving in that direction, and it will complete its distance at this particular point. So, whatever the distance covered by that particular particle, if we calculate it, then it is in terms of wavelength, right? So, wavelength it is always measured in meters. Now, if we say that we are using the microwave communication, then this wave is nothing but the wavelength. So, dear friends, always keep in mind microwaves are the waves which are having wavelength with very tiny distance, or whatever the distance covered by that particular wave microwave, it is very much tiny, so it will never indicate in microwave 10 to minus 6 as a micro, right? Now, let us have a look over the concept wavelength. So, wavelength it is always labeled with the unit lambda. Now, there is one more parameter we are always using while defining a signal, that is frequency of a signal. So, symbol for frequency it is f, symbol for wavelength it is lambda. So, lambda and frequency, these are the two symbols. Now, if we go through the relation between lambda and frequency, so lambda and frequency are related with each other with inverse proportion, right? So, if frequency goes on increasing, the wavelength goes on decreasing, and if the frequency goes on decreasing, its wavelengths get increased. So, they are having inverse proportionality. Now, if I want to remove this proportionality symbol, inverse proportionality symbol, then I can modify this equation as lambda is equal to c by f, where c is velocity of light, right? And f is the frequency, as all of we know. Now, the equation becomes c is equal lambda is equal to, now the value of velocity of light, it is always 3 into 10 raised to 8 meters per second, and the frequency is f. Now the microwave frequency range, it is always between 1 gigahertz to 1000 gigahertz. So the start frequency f1, it is 1 gigahertz, and frequency f2 as per the reference books. Now let us have a look over how to calculate the wavelength for frequency 1 gigahertz and how to calculate wavelength lambda 2 for frequency 1000 gigahertz. So it is totally a mathematical part. So let us have a look. So suppose if I want to calculate lambda 1 for frequency f1 is equal to 1 gigahertz, right? And also I want to calculate lambda 2 for frequency equal to 1000 gigahertz, right? So lambda 1 is equal to c by f1 and lambda 2 is equal to c by f2, right? So the value of c, as all of we know, that it is 3 into 10 raised to 8 meters per second divided by f1. Here also 3 into 10 raised to 8 meters per second divided by f2, right? Now let us substitute the value of f1. So 3 into 10 raised to 8 divided by value of f1, it is 1 gigahertz, right? Also here 3 into 10 raised to 8 meters per second, and value of f2, it is 1000 gigahertz, right? Now let us calculate the value for lambda 1. So 3 into 10 raised to 8. Now giga means 10 raised to power 9. So 1 into 10 raised to power 9. So it becomes 3 into 10 raised to power 8 into 10 raised to power minus 9. So we are shifting this denominator value to the numerator side. So plus 9 becomes minus 9 power. So it is equal to 3 into 10 raised to minus 1. So I can write it also 30 into 10 raised to minus 1 into 10 raised to minus 1. Simplifications I am doing here. So rather than writing 3 into 10 raised to minus 1, I am writing 30 into 10 raised to minus 1 multiplied by 10 raised to minus 1. So it becomes 30 into 10 raised to minus 2. So it becomes 30 centimeter, right? Similarly, if we calculate the value for f2, it is 3 into 10 raised to 8. Now 1000 itself indicates 10 raised to 3 into giga indicates 10 raised to 9. So 9 into 3, 10 raised to 12. If it comes to the numerator, it becomes 10 raised to minus 12, right? So 3 into 10 raised to minus 4. So that value comes in meters. So that value indicates it is in millimeters. It is in millimeters. So the value of microwave frequencies are always less than 30 centimeter, right? So approximately 30 centimeter is equal to 1 foot or 1 feet, 1 foot. So the wavelength having distance less than 1 foot are comes in the category of microwaves. So whatever the microwaves are having their wavelengths less than 30 centimeter or 1 foot, it may be in millimeters also. So that's why this is all about the range of frequency range of microwave. So in this lecture we conclude that micro itself tininess, so tininess of about what, wavelength, so combinedly it is called as microwave. So the microwaves are the waves having wavelength very tiny. So if the frequency range of microwave, it is frequency range of microwave, if it is 1 gigahertz to 1000 gigahertz, right? So wavelength of microwave, it is always less than 30 centimeter, that is 1 foot, right? So this is all about the introduction of microwave. So microwaves are the electromagnetic waves whose frequency range from 1 gigahertz to 1000 gigahertz, and for comparison we can say that it is always higher in than that of your AM radio station 1 megahertz. So these microwaves have a lot of application. In our next lecture we are going to discuss the different applications of microwave also. So we will stop here. Thank you very much.